In this lecture, we will learn vectors, like how to add two vectors, how to subtract two vectors, what is the geometrical interpretation of adding two vectors. In your physics course, definitely you learned that vectors are the quantity that have both magnitude and direction. For example, the force is a vector because when you open the door, then maybe you apply the force in one direction, but if you apply the force in opposite direction, then the door will closed. And scalar are the quantities that have only magnitude. For example, the height. When you measure your height, you only need the magnitude, you doesn't need the direction. Okay. And a non-zero vector v is a directed line segment from an initial point P to a terminal point Q. Now, this is a vector, and this P is called the initial point, like from where we are starting, and Q is called the terminal point. And it has a direction from initial point to the terminal point. If the length of this line is 0, then this vector we will call the zero vector. And zero vector doesn't have any direction. And we normally write vector in boldface type or give an arrow above it. So if v is a vector, then we write v, then give an arrow above it. Now, two non-zero vectors u and v are said to be equal if they have the same length and same direction. If they go same direction and they have same length, then that two vector will call equal. If you look at this graph, then the length of vector u and the length of vector v is same, but the direction is different. The vector u makes 45-degree angle with the x-axis, whereas v makes 60-degree with the x-axis. So their direction is different. So these two vectors are not equal, whereas these two vectors are equal. Now, scalar multiple of a vector v. If you have a vector v and if you multiply that vector by a constant c, where c is called scalar, then cv is called scalar multiple of v. If you think about a vector v, so it has a length and it also has a direction. Now, if you multiply this vector by 2, then what will happen? It will go in the same direction because we are multiplying by a positive number 2. And since we are multiplying by 2, its length will be double. Okay. And if you multiply by 3, then its length would be triple. It will come up to this. Now, if you multiply this vector by a negative number, suppose we multiply by negative 2, then its length will be double, but for this negative number, its direction will change. Okay. Previously it goes this direction, but now it goes in opposite direction. Now, to add two vectors, suppose you have a vector u, where this is the initial point of the vector u, this is the terminal point of the vector u. And you have another vector v, and the initial point of vector v is as the terminal point of vector u, and this is the terminal point of vector v. Now, if you add the initial point of the vector u and terminal point of the vector v, then this would be u plus v. And this is called the triangular method. It also called tip to tail method, because at this point you have top, sorry, u have tip and v has tail. You can add these two vectors using the parallelogram method. So if you draw the vector v here, so it would be like this. This vector and that vector is same, they are equal because they have same direction and same magnitude. And draw another vector u here, this u, then this become a parallelogram and its diagonal would be u plus v. So if you go u this direction, v that direction, then this would be u plus v. Or if you go this way, so this is v plus u, v plus u. Now to subtract two vectors, suppose u goes this direction and v goes that direction. Now if you multiply this v by -1, then it will go in opposite direction. So it becomes -v here. Now draw the same vector -v here and same vector u here. Now it becomes a parallelogram. Okay, it becomes a parallelogram and its diagonal will be u minus v. Okay, if you go this direction, then it becomes u minus v. This diagonal becomes u minus v. If you go this direction, you will get the same thing, -v plus u, the same thing, -v plus u. A vector v in 2 dimension or 3 dimension with the initial point at origin is called a position vector. It also said the standard position. So suppose you have a vector OP, its initial point is the origin and this is the terminal point. So if you consider the xy axis, so you will go 3 units along the x-axis and 4 units along the y units. Now this angle is 90 degree and it becomes a right angle triangle. Now if you apply the Pythagorean theorem, then the hypotenuse square equals to adjacent square plus opposite square. That means 3 square plus 4 square, which is 25, and if you take its square root, you will get 5. So this 5 is the magnitude of this vector OP. So if you have a vector v, then its magnitude is denoted by absolute value of v, and magnitude of v would be square root of x1 square plus y1 square. We apply the Pythagorean theorem here. Now vector normally represent by the angled bracket, because when we write the ordered pair we normally use parentheses. So to get rid of confusion, we normally write using the angle bracket. Now in 3 dimension, suppose you have a point or vector v, x1, y1, z1. So to draw the vector, what you will do, you will go x1 unit along the x-axis and y1 unit along the y-axis and z1 unit along the z-axis. So this is the terminal point of the vector and this is the initial point. Okay, this point P is in the space. Okay, now what would be length of this vector? Length would be this square root of x1 square plus y1 square plus z1 square. Now how did you get that? So if you consider this triangle, this right angle triangle, then this is the hypotenuse and this angle is 90 degree. Here 90 degree angle. So if you apply the Pythagorean theorem, this distance become square root of x1 square plus y1 square. Okay, this distance. Now if you consider this triangle, now this triangle, so if you apply the Pythagorean theorem again, you will get the magnitude of V as this. Now general representation of a vector in R3. Suppose you have a vector V and its initial point is P and terminal point is Q. So for this triangle, we can write as OP plus PQ equals to OQ. OP plus PQ equals to OQ. OP plus PQ equals to OQ. And we need to find PQ. So PQ would be OQ minus OP. And OQ is same as Q. So it is x2, y2, z2. And OP is this one. Now if you subtract them, then what you will do, you will subtract component wise. That means first component x2 minus first component x1, second component y2 minus second component y1, comma third component. Okay, so if you want to find the magnitude of this vector, so apply the same formula here. It becomes square root of first component square plus second component square plus third component square. Now let's discuss few examples. So we have a vector V and its initial point at A and terminal point is B. So initial point A and terminal point B. So it goes this direction. Now we need to find AB. So AB would be B minus A, or you can say OB minus OA. Okay, so B is 0, 6 and A, its coordinate is 2, 1. So 0 minus 2 comma 6 minus 1, which is negative 2 comma 5. Now the length of this vector would be square root of negative 2 square plus 5 square, which is square root of 29. Now if you want to draw this vector in standard position, like, then what you have to do, you have to go negative 2 units along the x-axis and 5 units along the y-axis. Okay, so this would be in standard position. Now in 3 dimension we have 2 points A and B. So AB would be B minus A. So if you calculate, you will get V as 0, 2, 3, and similarly its magnitude would be square root of 13. Now if you want to draw this vector, so we have to go 0 unit along the x-axis. Okay, that means we are not moving along the x-axis. We are not moving along the x-axis, but we have to go 2 units along the y-axis and 3 units along the z-axis. Okay, so this vector would be V. Now the standard basis in R2, I is 1, 0 and j equals to 0, 1 is called the standard basis in 2 dimension, and this is the standard basis in 3 dimension. Now why it is called standard basis? Because any vector can be written as a linear combination of this vector I, j, k in 3 dimension. Okay, and any vector in 2 dimension can be written as a linear combination of these 2 vectors. Now consider this vector 2, negative 3, 5. Then this can be written as 2, then 1, 0, 0 plus negative 3, 0, 1, 0, 0, 1, 0 plus 5, 0, 0, 1. Now if you multiply 2 times 1, so first component is 2, other two component is 0. If you multiply here, second component is negative 3, other component 0. Similarly here, third component is 5, other components are 0. So you are getting back this original vector. Now this becomes 2i minus 3j, this j, plus 5k. So we write this vector as a linear combination of the basis vector, standard basis vector. Now a unit vector is a vector that has length 1, and I, j, k all are unit vectors. Like if you want to find length of this vector, it would be square root of 1 square plus 0 square plus 0 square, which is 1. So it is unit vector. Now how we can normalize a vector? Suppose you have a vector b, a non-zero vector b, then the unit vector u that has same direction as b is given by this formula. That means if you divide the vector b by its magnitude, then you will get the unit vector which has length 1 but it goes same direction as v. For example, consider v equals to 3, 4. So the magnitude of v would be 5. Now if you divide v by its magnitude, it would be 3 over 5 comma 4 over 5. So we are claiming that this is the unit vector. Okay. Now to prove, find its magnitude. So if you find its magnitude, it would be 1. Okay. So this is the unit vector. Now for this example, we have a vector negative 2, 4, 2, and we need to find the unit vector which goes same direction as v. So first find its magnitude, which is 2 square root of 6. Now we need to divide v by its magnitude. So divide v by its magnitude, and this would be the unit vector which go same direction as v. Now in our next problem, it asks find the vector that has opposite direction of v with length 6. Okay. Now this unit vector u has length 1, but it goes same direction as v. Now if we multiply this u by 6, then its length would be 6, but it goes same direction as v. But here they ask we have to go opposite direction. So what we can do? We can multiply by negative 6. So if we multiply negative 6, it will go same direction, it will go opposite direction of v, and length would be 6. Now vector arithmetic. If you have two non-zero vector u and v, and c is a scalar, then if you multiply the vector u by c, then you have to multiply each component by c. So if you have a vector u 2, 3, 4 and you want to multiply by 5, then you have to multiply each component by 5. Okay, each component by 5. And if you want to add those two vector, then you have to add component wise. u1 plus v1 first two component, u2 plus v2 second two component, u3 plus v3 third component, which we already discussed in our previous example. There are few more properties here, you can look over it. Now suppose we have vector a and b and we need to find 2a plus 3b. Now if you multiply this vector by 2, then we will get 2a. So if you multiply by 2, 2 times 2 is 4. negative 4 times 2 is negative 8. 4 times 2 is 8. And if you multiply this vector by 3, we will get 3b. So 0 times 3 is 3. 2 times 3 is 6. And negative 1 times 3 is negative 3. Now if you add them together, you will get this vector. The orthogonal decomposition of a vector in R2. Suppose we have a vector v, xi plus yz. That means we will go x-axis along, we will go x unit along the x-axis and y unit along the y-axis. So this is vector v, and the length of this vector is absolute value of v. Now if you consider this triangle, this is a right angle triangle. This angle is 90 degree, and suppose this angle is theta. Now this adjacent over hypotenuse is, we know, cosine theta. Okay, so x over absolute value of v is cosine theta, and if you cross multiply, x would be absolute value of v cosine theta. And for this right angle triangle, opposite over hypo is sine theta. So y over absolute value of v is sine theta, and y is absolute value of v sine theta. Similarly, opposite over adjacent is tan theta. So tan theta is y over x, and x cannot be 0 because we cannot divide anything by 0. So the vector v equals to xi plus yg can be rewritten as absolute value of v cosine theta plus absolute value of v sine theta. Now if you factor out v, absolute value of v, then the vector v becomes absolute value of v cosine theta comma sine theta. Now in this example, we have given the magnitude of this vector, which is 4, and we have angle theta, which is 30 degree. We need to find the vector v. Okay, so we have given two information, magnitude and angle. We need to find the vector v. So v is absolute value of 4, which is absolute value of v, which is 4, and cosine 30 degree comma sine 30 degree, and you know cosine 30 is square root of 3 over 2, and sine 30 degree, its value is 1 over 2. So if you multiply by 4, you will get this answer. And finally, absolute value of v equals to 3, and we have given this angle. Okay, so the terminal side of this vector is on the third quadrant. Okay, third quadrant, and we know on the third quadrant both sine and cosine are negative, so it becomes negative cosine 45 degree and negative sine 45 degree. And cosine 45 degree, its value is square root of 2 over 2. Sine 45 degree value is same as cosine 45 degree, and if you multiply by 3, you will get this answer. Now you can get this negative cosine 45 degree in another way. So if you start from here, so the total angle is 180 plus 45, which is 225. So cosine 225 is same as negative cosine 45 degree. Okay. Similarly, sine 225 is same as negative sine 45 degree. That's the end of today's class. Talk to you next time. Bye.